Hello, in this video we are going to talk about face verification. Now what is the difference between face verification and face recognition? Let's talk about that first. Now what is verification? You have the input image and also you have the name or the ID of the person. So you have two things and you have to output whether the input image is that of the claimed person. How that can be done? Now because you have the ID or the name of that person, you can go back to the database and inside that name or the ID you can match your input image with all the faces inside that folder. You might have one image in that folder, you might have five or maybe hundreds of images of that person. You have to match and be very sure about yes, that face is matching. So the answer is yes or no, right? It is yes if the face is matching and it is no if the face is not matching. And what is face recognition? Now recognition has a database, let's say, of k persons. K can be any number. Get an input image and output the ID if the image is any of the k persons or not recognized. So in the face recognition system, what you have to do is you have to compare the input image against each and every person in the dataset, and if the face is not matching, you have to print not recognized. Now one-shot learning. So what is one-shot learning? Learning from one example to recognize the person again. Now you have to use let's say deep learning model. What you have to do is you have this database, this is the database, and you have these photos, these images that you want to recognize. So let's say that you want to recognize this face. So what you have to do is you have to convert this image into something which can be matched with the maybe embedding of this person or embedding of this person. Embedding means features of the face of that person. So you have to match each and every face with that particular face and then match the ID. So if this lady has the same face as this face, so we will say that ID equal to 2 is the ID of this person, right? And similarly for this face. So this is one-shot learning. You have only one image per person, and using single image of the person we are able to recognize the person which is being probed. So let's say that you want to check the similarity, right? Learning a similarity function. So you have to see what is the difference between two images. It is the degree of difference between images. And it has to be compared with a let's say threshold value of tau. If it is less than that value, the person is same. The two images are of the same person, and if it is greater than tau, the person is different and person does not exist in the dataset. Let's say that. You can see in this figure that in the dataset images we have 4 people and in the probe images we have 2 people, and this red arrows mean that the person's face is not similar. This person's face is not similar to all the faces in the database, so no green line here. And for this person we will see that yes, there is a green line here because the face is matching. Now how to calculate the difference we will see in the later slides. So what is Xiaomis network? Xiaomis network is a deep learning model which utilizes CNNs, right? Convolutional neural networks, and you can see here easily that if the image is of size 100 into 100 into 3, why 3? Because it is a colored image, 3 is the RGB channel. So you are passing it through the convolution, and in the last 2 layers you are having this fully connected layers. You are getting 128 features, 128 values out of this face. So this face which was initially 30,000 pixel values, this is converted into a 128 value array or a vector, which is denoted by fx1 here. This is called the encoding of x1. It is a 128 value vector. And similarly for the second phase we have this again 128 value vector. Now if you do the difference and getting the square of it, the absolute square of the difference, and this Xiaomis network has been talked about in this research paper of deep face closing the gap to human level performance. It came in 2014. You can read this paper for more details. Now what is the goal of learning? So we have converted this face into this f of x1, which is a encoding of the person's face. So parameters of neural network define an encoding fxi, learn the parameters so that x of I and x of j are of the same person. If they are of the same person, this value has to be small. Obviously the distance will be small because similarity will be more, the difference will be small, the square of that value will also be small. Similarly, if there are two different persons, xi and xj, difference will be more, so the square value will also be more. So this is the Xiaomi's model's method of checking if the two people are having the same face or not. Now triplet loss. This triplet loss came in 2015 in this research paper called FaceNet. So they used a clustering technique. We will be talking about that now. Let's say that you have two people. So you can see that the first three images are of the same person and the fourth image is of the second person. So there is a concept called A, P and N, anchor, positive and negative. Let's say that person A is having this anchor image. Now you have to select two images, one from the same class, this face is of the same person, and then also one face from the different class. So let's say you have 10 classes. Let's say this is class 1, this is class 9, randomly selected. If anchor is from class 1, the positive image has to be from class 1, then only the face will be matching. And negative, this n value can be selected, an image can be selected from rest of the 9 classes, from class 2 to class 10, any person can be selected. So let's say this is class 9, so A and N distance has to be more, for A and P distance has to be reduced. So this training is called triplet loss training. Okay, for more details you can go and read this research paper. Okay, now the loss function. Now we have to calculate loss function, then only we can try to minimize it. Given three images A, P and N, anchor, positive and negative image, you have to maximize this value of fa minus fp whole square minus fa minus fn whole square plus alpha, and alpha is the margin we need to keep here as a constant value, comma 0. So this equation should have a positive value, then only our loss will be more. J equal to sigma I equal to 1 to m loss of ai, pi, ni. So let's say that we have a training set of people, 1000 people are there and 10,000 images are there. You have to make triplets out of it, A, P and N, and while choosing a triplet it is preferred that A and P are of the same class and N is from rest of the classes that I have already discussed. So based on that, this loss value can be calculated. Now how to choose the triplet A, P and N? So during the training, if A, P and N are chosen randomly, DAP, the distance between A and P plus alpha should be less than equal to distance of A and N. It should be satisfied, and choosing the triplet that are hard to train on is preferred, because then your model is going to train better. So let's say that distance between A and P is 0.5 and distance between A and N is 0.7. You know that the difference is 0.2. Still we will try to bring this 0.5 to a down value, let's say 0.4 or 0.3, and we will push this 0.7 to 0.8 or 0.9. So that can only be done if the alpha is a good value. This alpha, the margin has to be at least maybe 0.25. If the margin has to be 0.25, then you have to bring this to 0.45, then only you have a difference of 0.25, or you can bring this number to a upper stage, so it can be 0.75 and the difference will be 0.25. So this alpha will play an important role for the training of triplet selection. Now for the training set using triplet loss, you can see clearly that all the anchor images are here and the positive images are here. So negative images, if the person's face is not matching, right? So these two people are same but this one is different, these two people are same but this one is different, here these two are same, this one is different. So this is how A, P and N should be selected: face verification and binary classification. So these two images are of the same person, so it is 1, right? So it is matching, so it is 1. And these two faces are of different people, so the face is verifying to be 0. and for this one again it is not matching, so face verification system will give output of 0, and here it will give 1 because the faces are matching. I hope all the concepts regarding face verification discussed in this video are clear. Thank you.